Imagine trying to build a house without a blueprint. You might have windows, doors, bricks, and beams, but without that blueprint, a visual representation of what the house should look like, you have no idea how each of those individual components need to go together, and the result is chaos. Let's compare this to data then. Data is the foundation of every decision, strategy, and business process in today's digital landscape. But without a clear structure, a blueprint, let's say, it's just going to be noise. And that is where data modeling comes in. So what is data modeling? Data models are pictures, a visual representation of how data is stored and related within an information system. They function as that blueprint to know how to design the information system. But data models also serve as a common language for communication among different stakeholders, all the way from developers to users. They help bridge the communication gap between technical and non-technical teams by providing a clear and concise way to discuss information structure. In this video, I'm going to focus my attention on relational data models, primarily because relational databases comprise the most common method whereby companies store their data. In Accounting 3510, you're going to learn a lot more about relational databases, query languages among other things, but this discussion will also touch on things we will be applying in Accounting 2500 as we merge and combine data. Relational data models consist of three main building blocks: classes, attributions, and associations. A class is a generalized category, a discrete collection of things whose data we want to track. Attributes are the specific things about a class that we're going to track. And then lastly, we've got associations. Different classes may be directly related to each other, and we explicitly designate relationships between two classes with associations. In a class diagram, classes are represented with rectangles, and depending on the level of detail within a diagram, this might just be a box with a single title of the class within it, or you might see the various attributes of the class listed below. Let's look at some examples. We could have a products class. That certainly seems like something where we want to track data within our company. So among the many attributes of our products class, we might choose to collect and store product IDs, names, descriptions, how much we sell it for, how much it costs, perhaps which supplier we purchase it from. Another example, our employees. Again, an abbreviated list of attributes here, an ID for each employee, their name and department, and we also have an identifier for each employee's supervisor. Let's keep working with the employees class and demonstrate how these things manifest in an actual database. Now realize, a data model is conceptual. A model visually shows the theoretical information structure. But once you're working with an actual database, we use different terms to talk about essentially the same thing. When working with a database, a class is referred to as a table. This is the employees table that tracks the data we indicated would be collected and stored per the employees class in our data model. Each of the columns in the table are referred to as fields. These are the attributes of the employees class. And each row of the table should reflect a unique observation or a unique instance of the class. In the database, these rows are called records. It's important to know both sets of terms and to remember which one is used for a conceptual data model and which one refers to elements of an actual database. Let's move on to that third building block, associations. Data is stored in tables for the sake of efficiency. But as you've seen in this class, it is often the case that data contained in one table is directly related to data contained in another. Previously, you've used lookup functions in Excel to handle data stored across worksheets. But now we're moving on to bigger and better things by actually putting together a relational data model, by specifying associations or relationships between two classes. Now, not all classes or tables are going to have these direct relationships, but for those who do, we formally specify these in a data model by connecting them with lines. For instance, we might have data about all of our company's employees stored in a table, and we might have in a separate table data about our company's various locations. If there is a direct link between data across these two tables, we can mark an association line between the two classes and set up a relationship in the database. Here we have a specific example. Dunder Mifflin is an office supplies distributor with employees working at one of 5 regional branch locations. Now, it's important to note that associations work in 2 directions, and you need to be able to describe how one unique instance of a class could associate with instances of the other. And this is going to depend on how the company does business. Given the information above, we see that any given employee works at one and only one location at a time. Specifying the association going from the locations class, a given location is going to have at a minimum one employee, but very likely associates with many employees. Thus, we have what is called a many-to-one relationship going from the employees to locations table. When indicating these relationships, you'll sometimes see it expressed with ones and m's. And when I say the word many, this just means multiple. It doesn't necessarily mean some large number, just the fact that a single instance from the location class could potentially relate to more than one employee. Let's try this again, but now in the context of business events. Obviously, companies are going to track data on their sales, but often they will separate out the event of cash receipts, the actual time when customers pay off their accounts. Now, how these classes might associate with each other, again, depends on the company doing business. Let's take the example of a jeweler that accepts installment payments for goods sold. A sale could potentially relate to many cash receipts. So going from sales to cash receipts, this is a one-to-many relationship. This could be entirely different for a different company, grocery store, or car dealership. So just be aware that when you're constructing a data model, it's important to be familiar with the business model because this can affect how you need to set up the information structure. Okay, just 2 more concepts, and then we're going to tie this all together into something useful. In a relational database, every single table is going to have a primary key. A primary key is an attribute that uniquely identifies each record or row in a table. Every record in a table must have a value for a primary key, and these values must be unique. No duplicates are allowed. Primary keys can be natural, derived from existing real-world data like social security numbers, phone numbers, or VINs for a car. This can be helpful because informed individuals will be able to specify what the value of a given primary key is. For example, you go to Smith's and they want to track your purchase back to you. So they're going to ask you for your phone number because that phone number is your primary key value in Smith's customers table. Now, while there can be benefits from these naturally occurring values, often the best primary keys are assigned sequential numbers because they ensure uniqueness without relying on external data. A foreign key, on the other hand, is a field in one table that serves as the primary key of another table within the database. This is what links tables together, establishing relationships between them. In a one-to-many relationship, the table on the many side is the one that gets the foreign key. Again, this creates a connection back to the table on the one side. Now let me be clear. It is perfectly okay for values within a foreign key field to repeat. What is important is that for any given value that a foreign key takes on, it should trace back to only one single row of the table where that same field functions as a primary key. For instance, here we've got customers and orders. The association between these tables is going to reflect a one-to-many relationship because a given order is going to correspond with only one customer, but a given customer hopefully will be associated with many orders. It's not like we sell to a customer once and we're done selling to them ever again. No, it's more likely that a customer could be associated with many orders. Since the orders class is on the many side of this association, the primary key of the customers table, customer ID, would be included in the orders table as a foreign key. Let's do another example. A logistics company manages customer orders for various retailers. A given shipment likely relates to several orders, but each order can be linked back to one single shipment. So what is the relationship here? It's going to be many to one. Many orders can associate with a single shipment. And since the orders class is the many side of this relationship, the orders table will host shipment ID as a foreign key. All right, now it's your turn. I'd like you to take the following opportunity to practice this. Read through the prompt above and consider between the two classes listed below, purchases and suppliers. And once you've read the sentences and are familiar with what's going on at the company, decide on what the relationship is between the classes and indicate which table ought to host the foreign key. So pause the video now and then I'll give a solution. Okay, a company purchases goods from a variety of suppliers. Most purchases reflect routine monthly orders. A given purchase order will correspond to, at most, a single supplier. This suggests that going from purchases to suppliers, this is a many-to-one relationship. We would expect to continually make repeat purchases from a given supplier, but any given purchase order will correspond to one and only one supplier. Well, since purchases is the many side here, we would expect to see supplier ID in the purchases table. It is the primary key of the suppliers table, but it functions as a foreign key in the purchases table. It is also possible for many-to-many relationships to exist between classes, but we're not going to go there in this class. Wait until your Accounting Information Systems course to learn how this complicates things and how to address it. In this video, we covered principles of relational data models because it is still the most common method of storing data today. You need to be familiar with the basic building blocks of a relational data model: classes, attributes, and associations. You'll also want to know how these terms are reflected in an actual database. Classes are identical to tables. Attributes become fields. We also discussed primary and foreign keys. A primary key is basically an ID field, something that takes on a unique value for every record in the table. To make relationships between tables work, these primary keys are posted to related tables, the many side of the one-to-many relationship, at which point they become foreign keys. Ultimately, all of this will become helpful when we begin to merge and combine data sets.